For decades, there's been one theory that seems to dominate the whole conversation about, well, everything. But today, we are diving into its biggest rival, loop quantum gravity. And this is a theory that basically wants to tear up the rulebook and rewrite reality from the ground up.
I want you to forget everything you think you know about the fabric of reality. I mean it. What if the space between you and me right now isn't some empty void, but a buzzing, frantic network of connections? What if, when you get down to the absolute smallest level, reality isn't smooth at all, but chunky?
You've definitely heard of string theory, right? It's the glamorous one, the ambitious theory of everything that gets all the press. But its main competitor, loop quantum gravity, takes a totally different road, and, you could argue, a much more radical one, by starting with our very idea of space itself. So you might be asking, why do we even need these wild theories? Well, it all comes down to the single biggest problem in modern physics, this fundamental split in how we describe the universe. We have one set of rules for the really big stuff and a completely different set for the really small stuff. See, on one side, you've got Einstein's general relativity. It's beautiful. It perfectly describes gravity on the cosmic scale. Planets, stars, entire galaxies. It's the playbook for the very big. But then on the other side, you've got quantum mechanics. This is the bizarre but unbelievably successful rulebook for the tiny world of atoms and particles. The problem? They both work perfectly in their own lane, but when you get to something that's both supermassive and super small, like the center of a black hole, the theories just, well, they break. They give you nonsense answers, like infinity. They just can't talk to each other.
So, the holy grail for physicists is to find one single quantum theory of gravity that can finally unite these two worlds. Basically, a theory that treats gravity not as some smooth, continuous force, but as something made of little packets, or quanta. And for a very long time, as we said, string theory has been the most famous name in that race.
But now, let's meet the challenger. Loop quantum gravity, or LQG for short. It might not get all the flashy headlines, but its approach to solving this massive problem is just as compelling, and it's fundamentally different.
And this is where you see a huge difference in their whole philosophy. String theory is going for the gold. It wants to be a theory of everything, explaining all the forces, all the particles, the whole shebang. LQG, on the other hand, is much more focused. It has one main target: solve that central conflict by figuring out how to quantize gravity. And in doing so, it wants to completely rebuild our understanding of space and time.
And this right here brings us to the single biggest, most mind-bending philosophical divide between these two theories. It all boils down to a simple question. Is space-time the stage where the action happens, or is it part of the action itself?
The key concept we need to understand is something called background independence. Now, I know, it sounds super academic, but trust me, it's a huge deal. It's the difference between a theory that just describes physics happening inside of space and time versus a theory that actually builds space and time from its own fundamental rules. Okay, think of it this way. String theory is background dependent. It's like you have actors, those are the strings, performing on a fixed, pre-existing stage. The stage, space-time, is just there. It's a given. Loop quantum gravity, though, is background independent. In this version, the actors are weaving the very fabric of the stage as they perform. The stage literally doesn't exist without them.
So, let that sink in. The crucial point is this. With string theory, you can picture strings vibrating in spacetime. But with LQG, you can't. You can't just plug the theory into a pre-made box called space, because the theory's most basic interactions are what creates space to begin with. It's a total shift in perspective.
So, if space isn't a smooth, empty backdrop, then what is it? And this is where LQG gets really, really wild. Welcome to the Spin Network.
According to loop quantum gravity, the fabric of spacetime isn't continuous. It's not this infinitely divisible canvas. Instead, it's quantized. Think of it like a digital photo. It looks smooth from a distance, but if you zoom in far enough, you see it's made of individual pixels. LQG says space is just like that. It's made of fundamental, indivisible chunks. You literally can't zoom in forever.
Physicists sometimes call these chunks the atoms of space. But, and this is the most important part, they are not tiny little dots sitting in space. They are space. Each fundamental unit, called a node, represents a quantum of volume. There's nothing in between them because there is no in-between.
So, how do you build a universe from this stuff? Well, you start with these nodes, these atoms of space. Then you connect them with lines or loops, and those loops define how they relate to each other geometrically. What you get is something called a spin network. And by the way, the spin here isn't about things rotating, it's a deep quantum number that defines the geometry of space itself. This incredibly complex web is the fabric of space.
So that smooth, continuous space we all experience every day, it's just an illusion. It's an approximation of this incredibly dense, constantly changing network of loops and connections. Reality at its core isn't stuff in a container. It's a set of relationships.
Okay, so we have two completely different pictures of our universe. Let's put them side by side one last time and really see how they stack up. All right, here's the final showdown. On one side, you've got string theory, aiming to unify everything by saying all particles are just different notes played by tiny vibrating strings. On the other side, you have loop quantum gravity, with its laser focus on quantizing gravity, proposing that space itself is a network built from these indivisible atoms. Two totally different philosophies, two totally different ideas about what reality is made of.
So what does all this actually get you? What does it predict? Well, LQG makes some incredible predictions. For one, because space has a minimum possible size, you literally can't shrink it down to zero. It means that singularities, these points of infinite density like the center of a black hole or the supposed start of the Big Bang, can't exist. They're impossible.
And just think about what that means for a second. If the Big Bang wasn't a singular point of creation that came from nothing, then what was it? LQG suggests it could have been a big bounce, the collapse of a previous universe that hit a maximum density and then bounced back out to form our own. It opens the door to a universe that might not have had a beginning and may not have an end.
So in the end, we're left with this really profound question. Is our universe, at its most fundamental level, a grand symphony being played on unimaginably tiny, vibrating strings? Or is it an intricate, evolving network of connections, a tapestry woven from the very atoms of space itself?
The truth is, we don't have the answer yet. Both of these ideas are still very much works in progress. But the search for that answer, this incredible battle between strings and loops, is pushing the absolute boundaries of what we know and what it's even possible to know about the true nature of our reality.